Hello guys, our today's topic is numbers and square roots. So first, numbers. We have natural numbers, whole numbers, integers, real numbers, irrational numbers, and rational numbers. First, what is natural numbers? The set of natural numbers is denoted by capital N. And the two natural numbers, we can say that they are 1, 2, 3, 4, 5, and etc. The set of all whole numbers is a set of natural numbers together with zero. It's denoted by capital W. Its numbers which is begins from 0. 0, 1, 2, 3, 4, 5, and etc. And the third is integers. The set of integers is a set of natural numbers together with 0 and the negatives of the natural numbers. It's denoted by capital Z. And they are, for example, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and etc. Then express rates between numbers and parts of wholes with rational numbers. For example, 8 over 3, 2 over 5, -3 over 7, 0 over 7, and 17 over 1 are rational numbers. The set of rational numbers is a set of numbers that can be written as a quotient of two integers. It's denoted by capital Q. Capital Q is, for example, Q is equal to A over B. And for example, there are some rational numbers, -7 over 2, -1 over 2, 2 over 3, 5 over 4, or 13 over 2. There are some decimals which do not repeat or terminate. For example, P or E or square root 2. They are not determined and do not repeat. Therefore, we can't write these decimals as rational numbers. We say that they are irrational. And the union of the set of rational numbers and the set of irrational numbers forms of the set of all decimals. This union is called the set of real numbers. The set of real numbers is denoted by R. And for example, these are some examples of real numbers: -2.35, -0.5, 0.6, E or P. From here we can see that all natural numbers can be whole numbers can be integers can be rational numbers, and the rational numbers and the irrational numbers together will be real numbers. Square roots. Remember that we can write a multiplied by a as a square. We call a to we square the square of a, and multiplying a number by itself is called squaring the number. The inverse operation of squaring a number is called finding the square root of the number. If a square equals to b, then a is the square root of b. We use the same symbol, this symbol, to denote the square root of a number, and we write square root of b like this. And so if a square is equal to b, then a is equal to square root of b. But there is one thing that we need to know. It's, for example, if x is equal to square root of 9 and the x square is 9 are not same things. Why? Because from there we can see that square root of 9 is equal to 3, and if there is writing that x square is 9, there x can be 3 or -3. Therefore they are not same things. Properties of square roots. Our square roots have several properties. For example, for any real number a and b where they are equal to or bigger than 0, they can be written like this. For example, here is some examples. And then second property. Second property is says that for any real numbers a and b where a or b are equal to or bigger than 0, we can write this like this. There are some examples, and then third property. Find real numbers a and b where a and b are equals to or bigger than 0. We can write like this, and we can use this, and we can use this property like this when we solve our problems. And there is our fourth problem, fourth property. It says that for any non-zero real numbers a, b, c, and x, we can use this property like this. A square root of x plus b square root of x minus c square root of x is equal to, in brackets, a plus b minus c, and the square root of x. And our last property says that let a be m and n be four real numbers satisfying that a is equal to m plus n and b is equal to m minus n. Then we can use these two properties to solve our problems. Square root of m plus square root of n is equal to square root of a plus 2 square root of b. Square root of m minus square root of n is equal to square root of I square root of a minus 2 square root of b. And there we need to know that there m must be bigger than n. Rationalizing denominators. Look at the numbers 1 over square root of 5 or square root of 3 over square root of 2, 10 over square root of 20, 12, and the square root of 19 over square root of 13. They are all fractions and each fraction has an irrational number as a denominator. In math, it's easier to work with fractions that have a rational number as a denominator. Therefore, changing the denominator of a fraction from an irrational number to a rational number is called rationalizing the denominator of the fraction. Rationalizing the denominator doesn't change the value of the original fraction. To rationalize the denominator, we multiply the numerator and the denominator of the fraction by a suitable factor. For example, if the fraction is in the form square root of a over square root of b, we square root of a over square root of b, we multiply both the numerator and the denominator by square root of b. So if square root of a and the square root of b we multiply by square root of b over square root of b, we can take that square root of ab over b, and it will be our answer. And we need to know that this and this are same things. They are same things. They have same value. For example, we can there see some examples. For example, if square root of 3 over square root of t, we need to take answer where denominator have no square root. And for this, we need to multiply both denominator and the numerator to square root of 2. And we can take from there that square root of 3 times 2 over square root of 2 times 2. It can be square root of 6 over 2, and it will be our answer. And there we have second type. An expression with exactly two terms is called a binomial expression. Two binomial expressions whose first terms are equal and the last terms are opposite are called conjugates. For example, a plus b and a minus b are conjugates. If a and b are larger or equals to 0, then the binomials x square root of a plus y square root of b and x square root of a minus y square root of b are conjugates. We can use conjugates to rationalize denominators that contain radical expressions. For example, let us rationalize 1 over square root of 3 plus square root of 2. Square root of 3 minus square root of 2 is a conjugate of square root of 3 plus square root of 2. Therefore, we multiply the numerator and the denominator by square root of 3 minus square root of 2 to rationalize the denominator. And from there we can take answer that will be square root of 3 minus square root of 2, and it will be our solution. To take this, we need to use these formulas here. How we see, for example, here we use this formula, and it says that square root of a in bracket square root of a plus square root of b times in bracket square root of a minus square root of b will be equal to a minus b. And here we use our this formula. That's all. Thanks for your attention.